Hello everyone, welcome to my channel. This is a channel for educational purposes, and today is our 264th video that we've done on the reciprocal system of theory. This is a system of theory, or theory of everything, that was promulgated by Dewey B. Larson in the 20th century. He died back in 1990, wrote books on a lot of different scientific topics, chemistry, physics, astronomy, also economics, and some metaphysics. And they're all based on the same theory. So he has one theory and says that you can plug that theory into every subject. Of course, he didn't have time in his 92 years to plug it into every subject, but he covered a lot of the bases, and some of his followers have moved his theory into other, even further afield topics. And we're looking at one of those today from Dr. Bruce Perret, who also unfortunately passed away a few years ago, I believe from cancer, and I could be wrong about that. He had a protracted illness though, but he did some monumental work, and to some extent almost as monumental as Larson's work, in terms of revising Larson's theory and extending it. He had something that he called RS2, Reciprocal System 2, the reevaluation of Larson's reciprocal system, where he took a few, he did this along with KVK Nehru from India, and they made a few major changes in the reciprocal system. Larson himself said that the system itself is correct. Whether I applied the system correctly is another matter, and if I didn't apply it correctly, those mistakes will show up eventually, and they will need to be corrected. And that's pretty much exactly what Perret and Nehru did, especially in terms of the photon, and with Perret also with the geometry of the system. Other matters as well, symbolism, and the scale of our universe, not in terms of both space and time. How big is our universe? How big is our capability of observing our universe? And how long have we been here? Is it billions and billions of years, or is it just millions of years? And he goes through all this in a number of different papers, but Perret wrote under the pen name of Daniel Phoenix III for many of his papers. They call the Daniel Papers, and Daniel Phoenix III was a character who was supposed to have worked on the Montauk Project with this is a top secret government black ops time travel project gone wrong, and that is I'm not sure whether Perret actually was one of the young computer programmers on the Montauk Project back in the 1980s, or if that's just his way of bringing these ideas to light. But anyway, we're looking at his paper that is called Extra-Dimensional and Extraterrestrial Entities. What is it called? Let me give you the exact title. Extra-Dimensional and Extraterrestrial Entities. And we started this yesterday, so we read the first couple sections, and we're going to get to the next section here. First, though, I just wanted to go through the reciprocal system real quick. because Perret does, I think, explain some of it in his paper too. But the basic idea behind the reciprocal system is that the universe is not made out of matter, and it's not made out of energy either. It is made out of motion. And for Perret, motion was the relationship between space and time. So that sets up a generalized reciprocal relationship between space and time. Hence the name, the reciprocal system. Motion is basically a fraction with time or space as the numerator and space or time as the denominator. Both of them have the same characteristics. Three in particular. One is that they have a coordinate aspect, meaning that they are 3 dimensions, or I would say 3 or 4 dimensions. And then they also have a scalar aspect. Larson calls that clock space, clock time. And that means that they are progressing. They're always moving forward. A scalar motion is a motion that has a magnitude but does not have a direction, or it has all directions equally. And so you would envision this with a balloon with a bunch of dots on it. If you blew up the balloon, the dots are moving away from each other, but in no particular or all directions. And that is the progression of time. Time is always getting later and later and later, but in no particular direction. And in the same way, space is always getting farther and farther and farther apart. Okay, and then 3 is the discrete unit postulates. Time and space both come in only discrete units. There is no minimum, there's no continuity of space and time. They come in chunks. There is a very small chunks, but there is a minimum unit of space and a minimum unit of time. And if you have exactly 1 unit of space in 1 unit of time, you have the speed of light. And so the speed of light is, for Larson, basically the midpoint of the universe. Half of the universe is moving faster than the speed of light. Larson calls that the cosmic sector. Half the universe is moving slower than the speed of light. And that is what Larson calls the material sector. And the material sector is where the legacy scientists do all their observations and measurements. The cosmic sector is relatively unknown to legacy scientists. But because of the reciprocal reciprocal system, the reciprocal nature of the universe, what's going on in the cosmic sector is exactly the same as what's going on in the material sector, except that you just have to switch the roles of space and time. Okay, now that's just the short version. There's many other aspects that you would want to get into, but basically Larson takes, that's basically his first postulate. And his second of 2 postulates is just that the universe conforms to the relations of ordinary commutative mathematics. Its magnitudes are absolute and its geometry is Euclidean. Perret took him to task on that Euclidean geometry idea and proposed projective geometry instead, which is just a more inclusive geometry because projective geometry includes Euclidean geometry as a subset. So now what Larson did then is he took those 2 postulates and he created an entire theoretical universe from that. So that's where he's saying, the system itself is correct. Whether I've applied the system correctly or not is a different matter. So he applied the system by, going deductively. Okay, if this, then that. If this, then that. Now, I did about 15 videos several months ago that you can find here on the channel called on his talk that is called the outline of the deductive development of the reciprocal system. So you can go through those videos and hear how he goes from one step to the next if this, then that, then if this, then that. And I believe he has about 165 steps where he derives, his universe from. So you can go check that out. Now, then once he wrote these books, put them out there, got a little bit of a small following, and had some other had a little journal called Reciprocity that published consistently for 20 years or more, and then after he died, some of his followers began to take over, including Dr. Perret here. So we're gonna start this paper that he wrote right from the middle, not the middle, toward the beginning. This section is called the time and relative dimensions in equivalent space. Coordinate time, and that basically, is meaning three-dimensional time, x, y, z coordinates. Coordinate time cannot be directly observed nor measured. We can only observe the effects on how time changes space. Okay, we were talking about this yesterday. We cannot see time. We only see space. So when we look at time, we only see it as it affects space. And I was using the examples of a magnetic field. That is something that is in time, but we do not see the magnetic field, but we see iron filings arranged in a pattern. That is how we see how time changes space. The iron filings are in space, but we see how they're affected by that magnetic field. Also, the other example was the white dwarf star. If you are exploding a star so powerfully that it goes beyond the speed of light, then that explosion is in time rather than in space. And we don't see time. So we can't see an explosion in space. We see an explosion in time. We see how it affects space, and we see the inverse. So instead of something exploding in time, we see something imploding in space. And so that is why a white dwarf star looks to be extremely small and super dense. Okay, Perret will probably cover this here, so let me get back to him. So how does time change space? There are two ways. One in the macrocosm, as we would see from iron filings orienting themselves in a magnetic field, or in the microcosm at the atomic level. Larson refers to the latter as equivalent space, which is the spatial equivalent of the temporal motion of atoms and particles. As already mentioned, the yin of time has an intrinsic polar or rotational nature. So when we try to express time in the linear system of space, it is a bit like Cro-Magnon man first encountering the wheel. After spending his life dragging loads on sticks in a straight line, if you were going to Bedrock University and Professor Albert Einstein, the local expert on temporal physics, gave a pop quiz with these two instructions, could you answer them? One, draw a straight line that is 45 degrees long, and B, draw two lines at a 45-degree angle. The first instruction is the problem with trying to express 1D temporal rotation as a 1D linear spatial concept. The second is the equivalent space solution. Does Einstein's quiz make you think enough to understand the problem? Question. Okay, just kind of looking at the footnotes here. Here he says, in the reciprocal system, atoms are temporal rotations existing at a coordinate spatial grid. Since we cannot directly observe time, we see the equivalent space as a hypersphere projected onto 3D as a sphere, a tiny round atomic ball. Okay, back to the text. Mathematically, time can be expressed by an imaginary number. Note that, and now you might have to go back to your high school algebra class to remember imaginary number is usually called I. That's the square root of -1. And then there are the other imaginary numbers j and k, and they are also square roots of -1, but they also can be multiplied together. Basically, what you're looking at with an imaginary number is a 90-degree rotation. Nobody ever taught me that in high school, unfortunately, and so it just went over my head. But yeah, it's a 90-degree rotation. So if you have I, you're talking about a 90 degrees. If you have I squared, that would be -1. So that is way over on the -1 axis there at 180 degrees. And then I cubed is then the 270 degrees, and the I to the 4th power brings you back to 0 degrees. Note that an imaginary quantity works just like a real quantity. It has a magnitude and is commutative in math. However, you cannot place an imaginary quantity directly on a real axis, nor a real number on the imaginary axis. They are mutually exclusive. That is where equivalent space comes in, a two-dimensional space that can express this yin quantity of time as a 2D spatial rotation. So when we go to measure the motion of time in equivalent space, all the dimensions are kicked up a notch. In coordinate space, the geometry is determined by the number of spatial dimensions. 1D line, 2D area, 3D volume. However, when we look at the effect time has on space, the equivalent space, the dimensions of time have this geometry. 1D is an area expressed as 2 spatial dimensions. 2D is a volume expressed as 3 dimensions, 3 spatial dimensions. And 3D is a hypervolume expressed as 4 spatial dimensions. Nature always expresses itself at the maximum dimension. In the microcosm, everything we view has 3 spatial dimensions. 1D and 2D spatial structures make for good science fiction, but have never been observed anywhere in nature. One may claim that an electric field is 1D and a magnetic field is 2D. And that is true, but neither are observable as a spatial dimension. The maximum dimension for the equivalent space of the microcosm is 4. When counting spatial dimensions, there are 3 in the macrocosm and 4 in the microcosm, a total of 7 spatial dimensions available to observation, which gives the 7-fold structure of our reality that is commonly recognized. The dimensional structure gives rise to associated densities based on the level of complexity contained in each dimension. The common structure looks like this from a variety of sources. Now, so he has a table here, and it has the densities. The first three densities are macro, meaning they're in space. And the 4, 5, 6, 7 densities are micro, meaning they are in time. And in the macro, dimensions 1, 2, and 3 are, he's done this in other papers, inanimate, biologic, and ethical, respectively. And then also in the Latin, that would be corpus, anima, and animus, or in New Age language, that would be body, mind, and spirit. You could also call those physical, astral, and causal. In Sanskrit, Sthula, Kama, and Manas. And these are the physical evolution of body, mind, and spirit. But then when you get to the micro, that would be Akashic, mental, messianic, and Buddhaic, or Buddhi, Atma, Anupadaka, and Adi. And he refers to that as internal ethics, intellect, agape, love, and achieving the divine. One can say that there is a clear break between third and fourth density, where the focus switches from developing the physical container of the body in the three-dimensional macrocosm, or ego, to developing the internal attributes that we associate with higher states of consciousness and the reaching out to the divine or higher self. The switch from space to equivalent space explains why this barrier is there. For when one crosses from the third density and into an equivalent space, they begin to have direct access to the dimensions of time and the mystical universe it symbolizes. Okay, I think we're going to stop there, and we will resume this paper tomorrow. All right, thanks for tuning in today, and have a great day.